In this video, two practical problems based on volume and speed is taken up. Okay, so the first problem. This is your first problem. Here what we are doing is, we are trying to irrigate the field with water from the canal. This is the main idea. So we are trying to irrigate the field from the water from the canal. This is, and the second is river water flowing into the sea. These are the two problems we are taking up in this video. The first problem. Let's read this question. Water in a canal 3 meter deep and 1.2 meter, 3 meter wide and 1.2 meter deep is flowing with a velocity of 100 kilometers per hour. How much area will it irrigate in 30 minutes if 8 centimeters of standing water is desired? This is what we want it to be. That is, we want to irrigate the field and from the water coming from the canal. Okay, the canal is 3 meters deep and 1.2 is 3 meters wide and 1.2 meters deep, and we want 8 centimeters of standing water. See how it looks. That's how the thing. So you see the water is standing up to a height of 8 centimeters and it's irrigating the entire field. Getting an idea? And we are irrigating it with the water from the canal. Solution. Water in a canal forms a cuboid of width 3 meters and height or depth as 1.2 meters. So when you say canal, canal is a cuboidal shape in this thing. So that's why we say it forms a cuboid of width 3 meters and height or depth as 1.2 meters. Length of the cuboid is equal to the distance traveled in 30 minutes with a speed of 100 kilometers per hour. Now you know water is flowing in the canal at a speed of 100 kilometers per hour. So how much that means in 1 hour the water which is accumulated over a length of 100 kilometers, that much water flows through the canal. But we want it only for 30 minutes. You see here 30 minutes. So in 30 minutes means 1 hour, 100 kilometers. So 30 minutes, it should be half an hour, that is 50 kilometers. So let's see this. Length of the cuboid will be 100 into 30 upon 60, that is 50 kilometers. But these measurements are in meters, so let's convert this length also in meters. 1 kilometer is 1000 meters, so 50 into 1000, that is 50,000 meters. Volume of water to be used for irrigation, that is the volume which is flowing into the field from the canal. So canal volume is L into B into H. Length which is said as 50,000 B and H. This is the volume of water to be used for irrigation. Water accumulated in the field forms a cuboid of base equal to the area of the field and height as 8 centimeters. 8 centimeters it is. We want everything in meters, so we convert this into meters, that is 8 by 100 meters. So area of the field is, that is length into breadth into height is the volume of water flowing into that field. So area of the field is equal to 50,000 into 3 into 1.2. This 100 goes to the numerator into 100 divided by 8. That is 22,50,000 square meters of area can be irrigated by the canal in 30 minutes. Okay, 22,50,000 square meters of area can be irrigated in 30 minutes. So why are we calculating and in what way? I said it is in the beginning, it's practical problems. So in what way now this, okay, I have calculated, I have know the calculations, I have done it. What way it is going to help us? It helps us to tell when to allow the water from the canal into your field and when to stop it. Because in the canal, water will continuously flow throughout the day. If you won't stop the water flow into your field, your whole crop will be submerged in water and it will destroy your whole or uh, destroy the whole field. So that's why we get an idea as to what to do when such canal facilities are available, when to start it, when to stop it, how much time it has to be allowed to water to flow into your field. All this will help us understand that when to stop it and when to allow the field canal water to get into your field. That is a basic idea behind all this. Now let's see the next question. This is your second question. A river 3 meters deep, 40 meters wide, is flowing at a rate of 2 kilometers per hour. How much water will fall into the sea in 1 minute? That means it will flow into the sea in 1 minute. This is a picture. This is a river. It is 40 meters wide, 3 meters deep, and this water is flowing into the sea here. Okay, water is flowing into the sea at a rate of 2 kilometers per hour. So in 1 hour, 2 kilometers length of river water is flowing into the sea. Okay, we want to find out in 1 minute how much it flows. Clear? So let us see. Solution. Width of the river is 40 meters. Depth is 3 meters. Length of the river be L meters. The water in the river forms a cuboid of width 40 meters, depth 3 meters, and length is L meters. The length of the cuboid is equal to the distance traveled by water in 1 minute with a speed of 2 kilometers per hour. So the length of the cuboid is equal to the distance traveled by water in 1 minute with a speed of 2 kilometers per hour. 1 kilometer is 1000 meters. This is a conversion. And 1 hour is 60 minutes. So if you see this, length of the cuboid will be 2 kilometers into 1000, that is 2000 meters, because all the other measurements are in meters, width and depth. So let us convert the length also in meters, that is 2000 meters. And per hour it is, let's convert into minute because we want it to be in 1 minute. So divide by 60. So 100 upon 3 meters. This is the length of the river water which is flowing into the sea in 1 minute. Volume of water flowing into the sea in 1 minute will be length into breadth into height. Length is this what we have calculated. Breadth is nothing but the width of the river and height or the depth is 3 meters. So this is 4000 cubic meters of water will flow into the sea in 1 minute. Now when you say cubic meters, you just can't visualize how much it is. So let us convert this into liters so we get an idea. 1 cubic meter of volume is equal to 1000 liters. So that means volume of water flowing into the sea in 1 minute is 4000 cubic meters. That is equal to 4000 into 1000. That is 40 lakh liters of water flows into the sea in 1 minute. This much is the volume of water flowing into the sea. Now see what an enormous volume of water is flowing into the sea. If this is the volume of water flowing into the sea in 1 minute, how much will it flow in 1 day, 1 month, sorry, 1 year? And what's this? This much water, when it flows into the sea, this water, river water, becomes salty, which is not fit for human consumption. And you know that river water is fit for human consumption. So that means this much water becomes salty and not fit for human consumption. So this led to a thought wave, thought process started. How can we prevent this water from getting into the sea? What is the procedure? So people started thinking on this, and this led to the building up of dams. The thought process, this calculation started a thought process of building dams. And today, there are dams all across the world in all the major cities, major rivers. So all the major rivers that we have built dams so that the water can be stored and used for any future use and used and is not wasted off and just put into the sea. So this is how we get to know that. And now the water is at our disposal and we can use it as and when we require it. And this way we are able to save the water and use it for human consumption. So such calculations give you an idea and give rise to a thought process which lets you start thinking what to do. So that is the basic idea for telling that these are the practical problems which were solved by human beings when they did such calculations. Thank you for watching. If you liked it, then subscribe, click the bell icon and share it with your friends.